The parent function of a square root function is just the square root of x. All right, the domain, x has to be greater than or equal to 0 because our domain is in the real numbers, and as you know, in the real number system, you can't take the square root of a negative. Our range is also greater than or equal to 0. Our intercept is 0, 0. So our x value is 0, our y value is 0. It is not defined when x is less than 0. And our end behavior, so what's happening to the end of the parent graph, is that x, as it goes more positive, it heads towards infinity, and as y, or f of x, gets more positive, it also heads towards infinity. So what it looks like, square root of 0, 0. I'm going to make the every 2 lines a 1, just square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3, right? So it's a curve. We also have this sort of non-existent part right here. So I just put that on there so you can see it's half of a parabola, right? X squared was a parabola going up. The square root of x is half a parabola laying on its side. To identify the domain and range, what we want is whatever is underneath this radical, it can't be negative because we're just talking about real numbers. So this has to be 0 or greater than 0. So to find the domain, oh, I don't want that in red. To find the domain, we actually take whatever is under the radical, so the radicand, and we set it greater than or equal to 0. And then we solve it. And this is our domain. And if we want to put it in set notation, it would look like that. Now, oops, that's a -4, sorry. Don't drop your negatives. Now to find the range, we want to actually solve it for -4. So I have -4 plus 4, so it's the square root of 0, so it's 0. So my range is that y, such that y is greater than or equal to 0. So we'll try another one. Here we have our radicand again is x plus 6, so I want to set that greater than or equal to 0. So x is going to be greater than or equal to -6. That's my domain. Because otherwise, if I put like -7 in there, I'm going to get a negative square root of a negative, which is not a real number, so it won't count. For my range, I'm going to plug -6 in. Okay, so that's the square root of 0 plus 2. So that's 2. So my range on this one is actually y, with y being greater than or equal to 2. Alrighty. Okay, translations of the square root functions. So you have, this is your basic, everything that can happen to you. Well, actually, that's not everything. There could be a coefficient on the x as well, but you can have a coefficient out in front of your root. You have your x, and then you've got something happening to the x inside, and then you have something happening on the end here. Okay. H inside is a horizontal translation, and this is sort of similar to when we had the translations with the squares and stuff. So if it's minus h, you're going to go h units right. So again, it's sort of the opposite of what you would think. So it's minus, but you go in a positive direction. And if you have plus h, you go h units left. So the h one is the tricky one. It's the opposite of what you would naturally think. Our vertical translations happen outside. That's k. And this one is sort of logical. If it's plus k, you go k units up. And if it's minus k, you go k units down. So inside the radicand tells us left or right. Outside of the radical altogether is up and down. If you have a, if it's a negative a, you flip over the x-axis or reflect over the x-axis. So instead of being up this way, we're coming down like that. Okay. If a, we'll just say absolute value of a is greater than 1. So 2, 3, 4, 1.5, anything like that, you're stretching vertically. So if your normal graph goes like this, you'd be more like that. You're fatter. And if your a is a fraction or decimal, so fraction, decimal, you're compressing vertically. So again, if your normal graph, say, was like this, your compression would put you down here, skinnier. Okay. Graphing them. Well, here I know I'm going to move 2 units to the right and 5 units up. But, you know, it's usually just easier to make a table. And what I want is I want to pick x's that will give me perfect squares. My smallest perfect square is 0. So I'm going to want this to be 0, so my smallest x will be 2. which will give me 0. So the square root of 0 is 0 plus 5 is 5. So I go 1, 2, 1, 2, 3, 4, 5. That's my first dot. My next perfect square is 1. So the x I want to pick is 3, because that will give me a 1. And then the square root of 1 is 1, plus 5 is 6. What's my next perfect square? Okay, 2 squared is 4, so my next perfect square is 4, so I want this to turn into a 4. So I'm going to pick a 6, right, because 6 minus 2 is 4. Square root of 4 is 2, plus 5 is 7. So here I am at 3, I go 4, 5, 6, and then I go just up 1 from where I was. And then your next perfect square is 9, so you'd pick 11. And then you get 3 plus 5, which is 8. So and then you connect your curve. Now this one, unlike when you make lines, it ends, right? We only have one arrow. This point right here, it stops there. It doesn't keep going anywhere. It's just, that's just it. So you have like part looking, I mean, it looks like part of a graph. Does that make sense? And as you can see, if our parent graph would have been 1, 2, 3, 4, 1, 2. Our parent graph would have been down here. And you see it's like the exact same graph, but it's moved over 2 and up 5. And that's what this told us, over 2, up 5.
How do you know accordance to
Hmm?
you have like the 3, 6?
Okay, so for this one, I have plus 3. So what I want to do is I want to pick something that will make that 0. So negative 3 will make this a 0. Times negative 2 is still 0, minus 1. And then the next perfect square I have is 1. So in order to make this a 1, I need to pick a negative 2. That will make that a 1. And then 1, the square root of 1 is 1. Times negative 2 is negative 2. Minus 3 is negative 3. My next perfect square, 4. So I plug in a 1. Square root of 4 is 2. Times negative 2 is negative 4. Minus 1 is negative 5. My next perfect square is 9. So if I plug in a 6 rather, I get 9. Square root of 9 is 3. 3 times negative 2 is negative 6. Minus 1 is negative 7. So I'm going to plot this. Negative 3, negative 1, negative 2, negative 3, 1, negative 5, 6. So 2, 3, 4, 6, negative 7. And again, that's only going one direction. And you'll notice here I went 5, 6, 7, 8. There's only one space in between each of my y values, like 1 unit. My a is a 1. Here my A is a 2, and you'll notice there are 2 units between each of these. 1, 3, 5, 7. So we've actually become stretched by a factor of 2. For our inequality, first we're going to graph the boundary of the equation. So we will graph this as if it's an equal sign. If the inequality uses less than or greater than, we're going to use a dotted line, and then I forgot to put the lines under these. I have to go back and do it because I didn't have those symbols. So if it's less than or equal to, greater than or equal to, so put your or equal to lines on there, please. We're going to use a solid line. We pick a point on one side of the line and plug it in. If we get a true statement, we shade that part. If we get a false statement, we shade the other. All right. So I want 0, so I'm going to plug in 4, and I get 0 minus 6, so that's negative 6. I want a 1, so I'm going to plug in 5, and I get the square root of 1, which is 1 minus 6, so that's negative 5. If I want a 4, I'm going to plug in 8, which will give me the square root of 4, which is 2, minus 6 is negative 4. And then I'm just going to come over here. If I want a 9, I would plug in 13, which would give me the square root of 9, which is 3 minus 6, which is negative 3. Okay, we have a less than, so we're going to need a dotted line. I go to 4, negative 6. That's my first dot. And then 5, negative 5. And then 8, negative 4. And then here's my 13, negative 3. It takes me right to the very edge. Oops. And then I want my curve to be dotted. Because I have less than. Okay. Now, less than logically is going to be probably right here, right? Less than is down. But we want to pick a number and plug it in just to be safe. So I'm going to pick some x. Let's say some x and y. So I go here, maybe this is 8. Maybe instead of 8, negative 5, I pick, or sorry, instead of 8, negative 4, I pick 8, negative 6. That would be this point right there. So I say negative 6 for my y is less than 8 minus 4, and then minus 6. So I've got negative 6 is less than negative 4. This is true, correct? So because it's true, I need to shade down here. Now, I have a boundary though. This end of my graph is my boundary line. I cannot shade past that boundary. I can't shade over here because I end right here. Oh. So I'm going to shade all of this. So any number I pick from here down would be a true statement. On to nth roots. Okay, actually, you know what?